Hey guys, Jake here, coming at you with another math lesson today, another live stream. Gonna be going over some integral stuff since it's the start of what is in a lot of schools winter term. A lot of people usually start with Calculus 2 at this point, so that's what we're gonna be going over today. As is the case with all my live streams, if you have any questions along the way, feel free to drop those in the live chat and we'll see what we can do to get whatever questions you have answered. Even if they're not on the topic of definite integral properties, which is the main thing that we're going to be going over today. Feel free to drop whatever questions you have and we'll see what we can do. But these definite integral properties, I wanted to talk about them because this is actually one of the topics covered on my integral calculus cheat sheet, my Calculus 2 study guide. And we'll just go ahead and start with kind of what a lot of those properties are, or the properties that are on my study guide. So this is just the little chunk of my study guide where I talk about the definite integral properties. If you do want to get this for yourself, I do have a link down in the description, and I'll put a pinned comment below with the link to that as well. But here is the main integral properties that you're going to want to be familiar with. So if you don't already know these, this is definitely a good kind of thing that you would want to take note of to learn or to memorize, or to have handy when you're working through any sort of definite integral, really. But I wanted to show you a couple examples of how to actually apply some of these properties. So we're not going to cover every single one of these, but a lot of them are going to be used in the problems that we're going to be going over today. So we'll go ahead and start with this problem here. We're going to write basically this expression that we have here as a single integral. So I have done another problem on my channel kind of similar to this, but this one is a little bit different, and I just wanted to kind of give you a little bit of variety and show you another kind of similar example to how we can apply these definite integral properties to simplify an expression like this down into a single integral. So in this case, it is a little bit more theoretical, right? We don't actually have a function for f of x or a function for g of x, but it really does illustrate something useful about using these definite integral properties, because if we did actually have some function for f of x and g of x, we could use these definite integral properties to combine this expression of three separate integrals down into one single integral, which hopefully, ideally, would be easier to solve than solving three separate integrals. So that's kind of the helpful thing about these definite integral properties. Well, as we kind of work through these, I'll show you exactly which properties from my Calculus 2 study guide we're actually going to use. And the first one we're going to start out with is, well, this is going to kind of use a couple all at once, I guess I should say. But really what we're going to be doing is to kind of keep in mind that if you have an integral of the same function, so in this case, let's just start by looking at these first two integrals here. So we'll start with this one and this one. We have the integral from 1 to 3 of f of x dx minus the integral from 2 to 3 of f of x dx. Well, we can kind of think of this in a couple of different ways, but since we have the same function that we're integrating, right, both of these integrate f of x, these definite integral properties tell us how we can kind of manipulate the bounds of our integral. So there's a couple ways you could kind of think about this. One way that probably would be the most intuitive would be probably to, instead of thinking of this as the integral from 1 to 3 of f of x, think of it as, and this is one of the properties on my study guide, is think of it as the integral from 1 to 2 of f of x dx plus the integral from 2 to 3 of f of x dx. And the reason why we want to do this is because now if we have this minus the integral from 2 to 3 of f of x dx, notice these two match up with each other exactly. We have the integral from 2 to 3 of f of x dx minus the integral from 2 to 3 of f of x dx. So as a result, if you have something minus itself, it's just going to cancel out. So these two this chunk of this first integral is going to cancel with the second integral we started with. And then we're still going to have the same thing over here, 16 times the integral from 1 to 3 of g of x dx. So now what we want to kind of think about is what we can do with this integral. And actually, I'm sorry, I made a mistake here. This was supposed to be a 2 right here. This integral over here should go from 1 to 2 of g of x dx. Wrote the problem down wrong. All right, there we go. So now that we have this integral here, let's kind of think about this last piece that we had over here first. One thing to kind of notice, first of all, is the bounds of this integral over here are the same as the bounds of this integral over here, which is nice because that, should hopefully, kind of give us a clue of which integral properties we might be able to use. And the one I'm referring to specifically is if we have the integral from a to b of f of x dx, and that was sloppy. Try that again. F of x dx plus the integral from a to b of g of x dx. This can simplify down into the integral from a to b of f of x plus g of x dx. So this is just something that is, pretty nice about definite integrals. If you have the same bounds on two separate integrals, you can combine them by simply adding, or if this was a minus sign, we could subtract whatever those two functions were. So based on the fact that we have the same bounds for this integral and this integral that we have remaining, if we can manipulate this last integral over here to get it so that we just have the integral from 1 to 2 of something, we can then combine that with our first integral over here using this property. So the question is, how can we get this to just be the integral from 1 to 2 of something rather than having this 16 out here like this? Well, another one of the properties that's on my study guide that I showed at the beginning of the video, and I can show that again here, is, and I don't think you can see my cursor now with this, but if you look at on the left side column, the third one down tells us that if we have the integral from a to b of some constant c times f of x dx equals some constant c times the integral from a to b of f of x dx. So basically what that tells us is if we have a constant being multiplied by an integral, we can move it into the integral and multiply it by whatever was in the integral, or vice versa. We could also do the opposite. So if we had a constant times our function within the integral, we could pull the constant out. Well, in this case, we're going to want to put it in. So what we can do is we can make this 16 times g of x dx. So now we have, kind of what we wanted to hopefully get, which is the integral from 1 to 2 of f of x dx plus the integral from 1 to 2 of 16 times g of x dx. So now what we can do, now that they have the same bounds, we just have the integral from 1 to 2 of this function here plus the integral of 1 to 2 of this function here. We can now apply this property over here, which tells us that this is going to combine down into the integral from 1 to 2 of whatever this function is, so f of x, plus whatever this function is, 16 g of x. So now what we've done is we've simplified these three separate integrals that were being added and subtracted together down into one single integral. Now we would just have to find the integral from 1 to 2 of f of x plus 16 g of x dx. And I'm sorry, I just realized I had some of this covered up over here on the left. So now you can kind of see this property a little bit better that we just applied here. All right. So that's it for that first problem. Let's not seeing any questions in the chat here. So we'll go ahead and move on over to the second problem I have here for the definite integral properties. All right. So here's the next problem we're going to be going over. We have if the integral from 1 to 5 of f of x dx equals 10, and the integral from 1 to 5 of g of x dx equals 2, we're going to find the integral from 1 to 5 of 8 minus 3 times f of x plus 10 times g of x dx. So this is going to use a few different integral properties. So again, if we go back over here, we have these integral properties that were covered on my Calculus 2 study guide. Like I said, if you do want to get that Calculus 2 study guide, I do have a link down in the description if you want to grab that. It's available for instant download. You can get a PDF of that pulled up and have that available as you work through your problems. But the in this case, we have a couple of different properties, again, that we're going to want to use. So the last example that we did, we went from 3 separate integrals and used these properties to combine them into a single integral. Well, in this case, we actually want to do the exact opposite, because what we are given here is some information about what the integral from 1 to 5 of just f of x dx is. We know that this whole thing, if we can get this somewhere in our equation, we know that this is all equal to 10. And similarly, we know that if we can kind of manipulate this, this integral here to get it so that we just have the integral from 1 to 5 of g of x dx, we know that we can replace that whole thing with 2. Well, we don't just simply have the integral from 1 to 5 of f of x dx or the integral from 1 to 5 of g of x dx anywhere in this integral, right? Because we have these other constants being multiplied by f and g. We have this other number being added in here. So we've got a lot of other stuff kind of along with the f of x and the g of x that we actually know something about. So what we're going to want to do is use these different integral properties that are covered on my Calculus 2 study guide in order to split this integral up into smaller, simpler pieces. Because what we're hoping to do is get something that looks like just one of these two things so that we actually know the value of that. So the first step in doing that is probably going to be to apply the integral property that says if we have the integral from a to b of f of x dx, and we are adding that to the integral from a to b of g of x dx, we can combine these into a single integral, which is the integral from a to b of f of x plus g of x. Well, the interesting thing about these integral properties is we can also go the other way. We can start with the integral of something plus something and split it up into these two separate integrals of, the integral of this first thing plus the integral of this second thing. So that's what we're actually going to do here. We're going to take this, and we have 3 separate pieces here that are being added or subtracted, and we're going to split this one integral into 3 separate integrals. So to do that, we're going to take, keep in mind with this integral property here, the bounds remain the same. This basically, applying it the direction that we're applying it, it means that the bounds of each of these two integrals are going to be the same as what they started with. So we're going to take the integral from 1 to 5 of our first piece, which is just 8. And then put a dx on there. And then we're going to do minus the integral from 1 to 5 of 3 times f of x dx, and then plus the integral from 1 to 5 of 10 times g of x. So this, split this one single integral into 3 smaller, simpler integrals. The problem we have now is these pieces here with our f of x and our g of x, they aren't just f of x and g of x like we were given. They still have these constants being multiplied. Well, another one of the integral property, or one of the integral properties that's on my study guide, is that if we have the integral from a to b, whatever a and b are, of some constant times some function, the constant can be pulled out. So this is going to be equivalent to the constant times the integral from a to b of whatever the function that was being multiplied by that constant is. So in this case, we have this first integral is not going to be changed yet. We'll deal with that in a moment. So we'll keep the 8 there. But then we have this 3 times some function f of x. Well, if we look back to this integral property here, we should be able to pull, if we go from this version of the property to this version, pull that constant out of the integral and have it times the integral out front. So what we can do is we can take this 3 and move it out in front of the integral, and then have 3 times the integral from 1 to 5 of just f of x dx. Then same thing here. We have this constant 10 times our function g of x. We can pull that out of our integral. So from 1 to 5, we'll have 10 times the integral from 1 to 5 of g of x dx. Okay? So now we still need to deal with this integral that is just the integral from 1 to 5 of 8 dx. So this is kind of weird because there's no function, or there's no variable, there's no, f of x or g of x that we were given some information about. So how do you deal with just the integral of a constant? Well, that is one of the other properties that's on my Calculus 2 study guide. So the property I'm referring to is the one that says the integral from a to b of a constant c with respect to x is just going to be the constant c times your upper bound minus your lower bound, b minus a. So as a result, we can apply that property to figure out that we're just going to get whatever our constant is that we're integrating times the upper bound minus the lower bound. So that's just going to be, in this case, 8 times our upper bound of 5 minus our lower bound of 1. So 5 minus 1. So that is going to simplify down to 4, or 5 minus 1 is 4, times 8 is 32. So we know that this integral here, the integral from 1 to 5 of 8 dx, is just 32. Okay, so now we can deal with these other two pieces, because now we got these two pieces to be exactly in the form that we wanted them to be, right? We have right here the integral from 1 to 5 of f of x dx, which is exactly what we were given here. We had the integral from 1 to 5 of f of x dx. And then we also have here the integral from 1 to 5 of g of x dx, which we were also given right here. Okay, so we know that this integral from 1 to 5 of f of x dx is just equal to 10. So we can replace this whole thing by 10. So we're just going to have 3 times 10. And then we know that the integral from 1 to 5 of g of x dx, this piece here that's in the box, is just equal to 2. So we're just going to get 10 times 2. So then we can simplify these pieces here. We're going to get 3 times 10 is 30, plus 10 times 2 is 20. Remember, order of operations, we got to do our multiplication before we do our addition and subtraction. So we'll do the 3 times 10 and the 10 times 2 first. And then we will have 32 minus 30 is 2, plus 20 is 22. So this expression that we had here, the integral from 1 to 5 of 8 minus 3 times f of x plus 10 times g of x dx, is all just going to be equal to 22. All right, and I'm not seeing any questions here, so we'll go ahead and wrap things up there. But again, these properties are in my Calculus 2 study guide. There's a link down in the description if you want to go check that out. Should be a huge help to you as you're working through Calculus 2 or integral calculus. So, hope you find some use out of that there. And I am doing these live streams every Monday night at 5 Pacific, 8 Eastern. And if you wouldn't mind giving a like to this video on your way out, if you got some use out of it, I'd really appreciate it. That would help, push this out to more people, and so we can keep growing the Jake's Math Lessons community and helping everybody do well all term long. So hope to see you next Monday night. Thanks, and see you then.